Hello student, myself Pranjal Kumar Matisya. So our topic is center of mass. So first of all, till now we have studied that kinematics and Newton's law of motion, circular motion and work power energy. But till work power energy, we have observed the motion of the object which has not any shape or size. Like that particle, that object is like a point particle. Okay, so we can say that if the block is at kept on a rough surface and it has mass sum m, so we can say that normal is upward and mg is downward. Okay, so here we can assume that the block is like a point particle, so where mg is only at a particular point and normal will be particularly upward at that particular point. Okay, but what happened if we have object which is not like a point particle, like suppose this block, if we not consider it like a point particle, then every particle has some mass inside the block and it has some dm into g, dm into g, dm into g will be downward and हर एंड इसमें जो होगा आपका हर एक पार्टिकल पे एक नॉर्मल ऊपर की तरफ लग रहा होगा dn dn dn. Okay, so basically actually basically in practical life, not all object is like a point particle. Okay, and one other example is like if we have a ball and if we throw it at some angle theta, so it will go to the upward and will come to the downward and it will follow the projectile path. But suppose if you have a pen and you throw it at some angle from horizontal at theta angle, so what will be the actual path of this pen? So basically the pen will go upward and its orientation will be like this. After some time it will be like this shape, and after some time it will be like this. So basically the orientation of pen will be like something this, and finally it will comes to the uh, ground. Okay, so if we observe the point which is at end of the pen, so it is initially here and after some time it will be here, 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 after some time it will be here. And if we trace the path of this point particle, so it will be like that some. So this is not the projectile path. Uh, if we if we observe the if we observe the nib of this pen, so it is initially here, after some time it will be here, after some time it will be here, after some time it will be here, here, then here, then here. So it is also not following the actual projectile path, but we can say that one point inside the pane, one point or one particle inside this pane which have actually a projectile path, so that point is center of this pen. So we can say that if the center of the pen is here initially, after some time it will be here, 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 and after some time it will be here and here. So if we trace the path of this point particle center of this plane, so we can say that it is actually follow the projectile path. But all other points inside the plane actually not follow the projectile path. Okay, so here one problem is that if we have an extended object, and we have to use the kinematics or dynamics, then it is very difficult for us to analyze the dynamics and kinematics of the extended object, because it is not the point particle and its velocity, its path all are different for different particles. And so So in this case, center of mass concept will be very helpful for us to analyze the kinematics and dynamics of the extended or continuous object. Suppose one more example. Suppose we have a rod, okay, and rod is hinged at one end, and we give some velocity omega, some angular velocity omega. So rod is made up of a lot of particles, and if we observe the first particle, and this is second particle, this is third particle, this is fourth, and this is fifth. The first particle will have velocity v, and second particle will have velocity v2, and third particle will have velocity v3, and fourth particle will have velocity v4, and fifth particle will have velocity vp. Basically the velocity of particle 1 will be less than velocity of 2, and velocity of 3, and velocity of 4, and velocity of 5. And if we have to calculate the linear momentum of this rod, then it will be very difficult for us to calculate the linear momentum of the rod, because every particle inside the rod has a different velocity. And so if we wants to calculate the linear momentum, then we have to add up all the momentum, like p1 vector plus p2 vector plus p3 vector plus dot 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 so on. So that will be the net momentum. But we can say that, बट आगे वी विल आगे हम लोग ये देखेंगे कि अगर मैं यहाँ पे एक ऐसा पार्टिकल लेता हूँ जो इसका सेंटर ऑफ मास का पार्टिकल मैं बोलता हूँ, और उसकी अगर वेलोसिटी वी सी ओ एम, वी विल कंसिडर इट एज अ वेलोसिटी ऑफ सेंटर ऑफ मास, देन नेट मोमेंटम ऑफ द पार्टिकल विल बी टोटल मास ऑफ द system, also total mass of the rod and velocity of center of mass. We can say that. We will see how it is possible in for the basically we in this lecture we only focus on the problems will come, and what will be the concept behind that, by which we can easily tackle this type of problem. Okay, so basically center of mass is the concept is made for extended or continuous object, for which we can very easily analyze the motion of the any continuous any extended object. Okay, and so a center of mass is the very essential concept to analyze the motion of the any continuous object. So basically we have to calculate the we have to calculate the uh, center of mass of any object. Okay, so for point particle, center of mass for point particle. So for point particle, let's suppose we have a system of particles, and in y, x, and in z axis, this is m1 mass, and its coordinate is x1, y1, and z1. And let's suppose m2 mass, its coordinate is x2, y2, and z2. Let's suppose we have a m3 mass, and its coordinate is x3, y3, and z3. So center of mass uh, for m1, m2, m3 particle will be, it has a x center of mass, it has a y center of mass, and it has a z center of mass. So x center of mass will be calculated by m1 x1 plus m2 x2 plus dot 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 divided by m1 plus m2 plus dot dot dot, and y center of mass will be calculated by m1 y1 plus m2 y2 plus dot 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 divided by m1 plus m2 plus dot dot dot, and jet center of mass will be calculated by m1 z1 plus m2 z2 plus dot 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 divided by m1 plus m2 plus dot dot dot. So this is the formula to calculate the x coordinate of center of mass, y coordinate of center of mass, and z coordinate of center of mass of any system of point particles. Okay, so this is the formula, and this is the formula. And if we have a position of point particles like r1 vector, r2 vector, and r3 vector, like this, if we have not coordinate, if we have a position of the point particles, then the position of center of mass will be m1 r1 vector plus m2 r2 vector plus dot 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 divided by m1 plus m2 plus m3, like this. So these are the formula to calculate the uh, uh, calculate the center of mass for the point particles. Okay, now we will see the some examples and some questions on the uh, center of mass for the point particles. Okay.